Oh, I kind of went live. That's great. My mic is on. We're 1 minute early, but I have a lot of information to go through because this is a performance talk, so I have to go really, really fast. Literally, I've given this talk before at that conference, so it's camping themed, and it's a 50-minute talk that I've condensed down into 30 minutes by eliminating 100 slides, and I still have 100 slides. But don't worry, I have a coffee break after this, so it's going to be good. I wish the coffee break was before so I could have a little bit of coffee, a little bit more caffeine, get me more hyper, but I'm naturally a hyper person anyway, so I'm going to give it another 10 seconds and I will formally introduce myself and kick off. Then again, I do have a live mic. I might as well just kick off. All right, hi everyone. My name is Lorenzo, and this is a talk about performance. And I like to start off with why are we talking about performance, which hopefully if my clicker goes, there we go. The reason why performance is important today is because more visitors are visiting your sites on mobile platform than ever before. It's actually surpassed desktop, and mobile phones are inherently really, really slow. And Google tells us that speed is really important on mobile. They have great articles and great numbers that say that 53% of users who are visiting your sites abandon a site that takes longer than 3 seconds to load. And the corollary to this is that mobile pages that are 1 second faster means they experience up to 27% increase in conversion rate. To summarize that, performance is your #1 feature. That is how you make money. The faster your site is, the more money your site will make. But for me, it's more than just the money, right? Like, I'm a web developer. I've been a web developer for 15 plus years. And speed is important to me because I'm constantly building sites and single page apps. This is XFI. My team and I worked on this. And it is a site that allows our customers to control their internet. You can actually pause devices. And like, if your kids aren't listening to you, you can shut off the internet on them and set bedtime routines. That's kind of like the benefit of this site. And this is a single-page responsive site that works great on mobile phones. And it weighs in less than 1 megabyte. But I work at a large company called Comcast. It's a Fortune 50 company. And we always build native apps as well. And as a web developer, I'm like, why are we building native apps? I hate native apps. We can do it on the web. The web is so great and awesome. And we go ahead and we always build a native app, and the native app is 75 megabytes in size. It's just huge. And I really struggled with this of like, do we really need to build a native app? And luckily, there's a great article by a Googler called Owen. And in this article, he kind of summarizes it. It says, you need to build both. Because websites let you reach users, and then native apps allow you to engage users. Because, spoiler alert, you can't outrun a bear. Bears run twice as fast as humans, and as web developers, we are never going to be as fast as native apps. And this really affected me deeply. Like, I climbed up a mountain, and I sat there somewhere in Vancouver, and I pondered, like, then, if we're not going to be as fast as native apps, what is our goal? What are we trying to accomplish? And Alex Russell tells us that our goal as web developers is to load a site in 5 seconds. It has to be interactive in 5 seconds. And for repeat views, you have to have it ready in 2 seconds. And interactive is more than just server-side rendering, right? You can't just display something on the screen quickly and say, great, that's a great experience, because the JavaScript still has to be there too. The user has to be able to see the site, be able to click on things, and actually be able to use the site. So server-side rendering is not a great solution. If you want to get your site interactive in 5 seconds, you can send down 170 kilobytes of JavaScript. That is your budget. That is the max that you're allowed to send down. And there's more to it than just speed, right? We want to look and feel like a native app. We want to be closer to native apps. We want to have that great experience. And that's what PWAs offer us. They allow our apps, our websites, to feel like native apps. We now have space on the home screen where we can add an icon. We can have a splash screen. We can go full screen and not have to show our URL anymore. And that's really the great part about progressive web apps. And they also do push notifications, which could only be done on native before. And then service workers are just really complicated, and there's been plenty of talks on that. But service workers really are great for those repeat views. It does nothing for the first initial view, but for the repeat views, we can easily get it in under 2 seconds because we can load everything from a cache. So for the rest of this talk, I really want to focus on how do we get interactive in 5 seconds, because this is really hard. And he's not going to outrun the bear either. He's a sprinter, still not faster than a bear. And the first thing you need to do is measure performance. Because if you can't measure it, you can't improve it. Some wise person once said this. And the best way to measure your performance is to use the user timing API. And at Comcast, we have an open source library created by John Riviello in the front here called Surf and Perf. And he actually is a surfer. That's why it's called Surf and Perf. I can't. I don't surf. But he does. And what the user timing API allows you to do is if you do a performance test, there's a whole section in here that allows you to set marks in your application to say how long it took for something to happen. So here we have a mark to know exactly when the user started going to our site and when our app was ready. And that's about 3.76 seconds. And the benefit of this is you actually push this out in the wild and you can send it to your logging infrastructure and get real user metrics on how long your site's taking to load. If you do add user timing stuff, make sure it's actually measuring the correct thing. So here we're logging that our splash is dismissed in 2.5 seconds. But if you actually look in the screenshots in the top, you actually see that the splash gets dismissed in 3.1 seconds. And the reason for this is a lot of times developers will call the function to dismiss the splash. That's actually really hard to say 5 times fast. And then they immediately set the mark that it was dismissed. And really what you have to do is you have to wait for the next animation frame to happen, because your JavaScript engine might be doing additional things before it actually gets to recalculate the styles and update the DOM. So follow this kind of format to make sure your marks are in the right place. Additional ways of doing measurement on the web is to use the audits tab. So Chrome recently added like this Lighthouse tool into the Chrome developer tools. And if you are new to web development and performance, like just run the audits there and it will tell you exactly what to fix. It has in-depth guides there for saying like, hey, look at this thing and look at this thing and look at this thing, and it will tell you exactly why and what to do to make it faster. And the best part about Lighthouse is it also works on the command line. So it's a standalone tool that you can install in your continuous integration environment, have it run with your builds automatically, and you can store the results every build. So you can see over time what the effect of your performance is happening. And so now that we've measured, we need to understand like what's actually affecting our startup performance. Does everybody follow Adi Asmani here? He's like one of the Google Chrome core developers. If you don't follow him, you have to. He has written a series of articles about JavaScript startup performance. And he summarizes it as less code equals less parse compile, less to transfer, and less to decompress. Thank you, that's all for the talk. Send down less code, you're done, that's great. And that's really the summary, right? Because he actually has this measurement on CNN.com, which is a news site in America. And he shows the iPhone 8 going to CNN.com, and that takes about 4 seconds to parse the JavaScript that CNN sends down. And if you compare that to the baseline phone that, you know, my mom has, or my grandmother and stuff, she might have a Moto G4, and that takes about 14 seconds to load that same site. And that's just to parse the JavaScript. It's 9 seconds longer than the iPhone. And a lot of your typical users do not have the latest iPhone X. They don't afford $1,000 every year to buy the latest and greatest phone that engineers take for granted. And really this means we need to pack less code. We need to be sending less code down on our sites. And that starts with your framework. At Comcast, we use every single framework that exists. This is our XFINITY mobile site, and it's made as a sales site to sell phones, and it's built with Angular. And I'm not picking on Angular, but I like to do performance tests of random sites at Comcast, and I actually don't have enough time to let this fully run, this animated GIF, for how long it takes for the site to load. So yeah, it takes over 30 seconds to load that site on a mobile phone, which is awful, like awful. And in the performance tools, you can simulate a mobile phone by just setting the network to a fast 3G and a CPU slowdown of 6x. And Rich Hickey has a talk called Simplicity Matters, where he says programmers know the benefits of everything and the trade-offs of nothing. And this is such a true statement for web developers today. And I want you to remember this, because I'm going to go into detail about this as we go through this. And the first thing that when you evaluate a framework, you really need to take into consideration its size. Angular is 57 kilobytes. Yeah, it does a lot. It does amazing things. But if you're building a simple promo site, you probably shouldn't be using Angular. You should look for something smaller, because smaller will load a lot faster. It's a lot faster for performance. And there's more than that, right? So Preact is only 3 kilobytes in size, and it has like a very similar API to React. And Adi Osmani has done case studies with some major corporations who have switched from React to Preact in production, and they noticed a 15% improvement in time to interactive. That is a lot of money, especially for major corporations, that they're saving. And it's more than just a framework. Like, as soon as you say, hey, I'm going to use React, that's great. Now you need React Router, and then you're going to be like, I'm going to throw in Redux, and then I want to use RxJS, and then Redux Thunks, and then React, I said React Router already. I mean, there's like so many libraries that you're using, and eventually your Webpack bundle analyzer shows you all these packages that you're throwing in, because everybody's using Lodash too. And make sure you're tree shaking Lodash out so you're only using the functions that you have in there. But your bundle size just blows up dramatically. And so I want to talk more now about XFi and how we built this site. It's written in Google Polymer using web components, which is like unheard of today. If you're interested in learning how to build an app from scratch in Polymer, check out Kevin's talk on it. He does a great job. He talks about a lot of patterns that we use for our site, like the purple pattern and the app shell architecture, which I don't have a whole lot of time to go into. But the critical path for the XFi site is we need to authenticate the users, and then we need to start making API calls right away, because our API, it takes about 3 seconds to get all the information for a user and the devices on their network. And then we want to start displaying the view for our user. And a lot of times when you build your site, you have like a root component, like XHapp, and then inside of that component, you're then doing authentication, you're starting to make API calls, and then you're showing the login page or doing else you need. And the problem with this approach is that your framework and your components, they require time to start up, and they are not the critical path. You want to do those other things first. And you have to remember that the browser is like its own framework. Like, it can execute JavaScript outside of React and outside of Angular and outside of all those other things. And you do that by making your authentication and your network calls happen at the top. So you break them out and just make it plain JavaScript and do that first. Then load the polyfills that you need, then load your library, and then load your application. Load your view. And so now we did a performance test of XFi, and I did a lot of research and work into making the site faster. And when I first started on desktop, our site was taking approximately 6 seconds to get fully interactive. And that's on desktop. And you got 5 seconds on mobile, so this is not good. The bear got us. And the first thing that I noticed was that rendering, this purple line at the top, was taking approximately 1.7 seconds. And it should never take that long for your browser to calculate styles. And sometimes solving performance issues takes a lot of time, and it's like looking for a 4-leaf clover. You just have to get lucky. And I'm a pretty lucky person. And I actually found a bug in Chrome because our site was using a lot of CSS properties, which is a new thing that allow you to do kind of what Sass has done for a few years of defining properties and then using those variables in your CSS. And all these custom properties that we were adding were being added to the HTML root element only. And I added a single custom element to the body tag, and that dropped our recalculation of styles from 500 milliseconds to 65 milliseconds, which is more in line with what it should be. And if there's any Chrome developers here, please fix this. Thank you. More things that you can do to get more efficient rendering is to have an optimal DOM tree. So this is what Google puts out. They say have less than 1,500 nodes in your DOM tree, have less than 32 depth, and no parent should have more than 60 children. I have 2 children, and that is plenty. If you have more than 60, well, just don't. It's computationally intensive. And one way of doing this is, so this is our people profile page, and it's a sub-child of the people page, like an entity page. And a lot of times what you'll do to accomplish this is you'll have your main router, and then you'll have all the pages, and you'll have your people page, and then the entity page is a sub-page of that. Anything that can go full screen on your site, move it up into the top level. Don't make it nested. Like, we think of it naturally as nested, as needing to be a descendant, but the browser doesn't care, and you want it at top level because then the CSS will calculate a lot faster. Next, I want to talk about API requests. Like I said, this was our critical path, and there's about a full second in there where we're actually not doing any JavaScript. And when our browser first loads, it takes 3 seconds from making that initial call to where we get our data to where we can actually display something. So we need to optimize for as soon as that initial HTML payload comes down, we want to make that first initial call as soon as possible. And right now we're delaying 150 milliseconds. So this is an opportunity for us to optimize that, to pull that call out higher in the JavaScript that's loading and make that happen as soon as possible. And there's other ways of optimizing this. So you can tell the browser with preload and DNS prefetch that, hey, I'm going to call this other thing. I'm going to need it later on. Call it now and have it in your cache already so that when the JavaScript does come, you'll already have it. Another thing to note about fetch requests or HTTP requests, the beginning of the box there is how long it took to connect to the server. The gray line is when the response was returned from the server. And then that long trailing line is when the response is processed. And that was taking about 400 milliseconds before our browser processed the response. And that's because the main thread is busy. JavaScript only has one thread. It can only do one thing at a time. And if it's busy loading up your framework, it is not processing your HTTP responses or your AJAX calls that you're making. So if network is important, make sure you're optimizing for that. Next, I want to talk about splash screens. Everyone has loaders. If you do a loader like we had, our loader was showing up approximately 1 second before it started rendering. And you see all that yellow that was happening? That's all the JavaScript that's happening before our splash screen loaded. And what you want to do is you want to load your splash screen and your initial screen outside of your framework. You should not be doing this in React or Angular or Polymer. You should make that base HTML and CSS on the page. And I was able to do that, and I got it to render in 0.2 seconds. So now my user will see something almost instantly as soon as they navigate to our page. And you want to take all your script tags and all your things that are not part of that initial splash and defer them. And you want to put them at the top of your index page, no longer at the bottom. Put them at the top, and that way the browser will start downloading them as soon as possible. And it will wait until after the whole page is processed, and then it will start executing the script tags in the same order that they showed up on the page in the DOM tree. Next, we had this rendering issue. Every time you see that purple mountain, that is rendering happening. And the images show that the splash screen is up the whole time. And I was like, well, what the heck is rendering? And a lot of times, you put the splash as a Z index over top of the rest of the site. And everything else underneath of your splash screen is still rendering. The browser is still calculating that. And what you want to do is anything that's under the splash, set it to display none. Make sure the browser isn't spending time calculating the styles for things that's not even on the screen. You might not have to use that exact CSS. The other thing is that we were spending a lot of time recalculating styles on startup. And there's things that you want to watch out for when you're starting up your application. And the great thing about the Chrome developer tools is you can actually click on that purple line, and Chrome will tell you, hey, I have a style that I need to apply, and recalculation was forced at line 398 in SI app. And there's a lot of things that force recalculation of styles. Paul Irish has a gist on them. And it's basically anytime you ask where an element is on the page, or what size it is, what's the width, what's the height, that forces a recalculation of style. In our instance, we were actually focusing on an element for accessibility. We wanted to tell the browser that stuff was happening. And as soon as you do that, the browser has to stop processing JavaScript. It has to recalculate styles, and then it has to give you the result, and then it goes back to doing things. And it gets really expensive. And we were doing this multiple times. So here's another instance where a dependency of ours, this iron fit behavior, which is for our modals, we were loading that on the screen. And during its attached method, it was calling getComputedStyle to figure out whether the text was going from right to left or left to right. And we only do right to left, so we didn't even need this. And the great part is, like, they're trying to cache this, but the problem is we load 27 different dialogues on our site. So 27 times it was calling get computed styles, forcing a recalculation of styles, adding like hundreds of milliseconds to our startup time. So I ripped that out and forked it and got away with that, and now our site's a lot faster. After you optimize a lot of the recalculation of styles, you want to check for expensive JavaScript. So we do a lot of date processing, and here in this calculate series, this was taking about 50 milliseconds, and we were comparing dates. And a lot of people here probably use moment.js, like we do, and this is a very simple function that's just comparing two dates. And I switched it by just using the built-in date operator in JavaScript, and that shaved off 45 milliseconds, because moment.js does a lot to instantiate its objects. And with all these changes, I was actually able to get our site from 6 seconds down to about 2.3 seconds, which is pretty darn good. I pushed out some of these changes, not all of them yet, and in the real world, we went from 21 seconds average load time to about 15 seconds. So we have great reporting and great metrics around like how long our site's taking, because it's important to us. And in summary, hopefully everybody's still good. This is my daughter. She falls asleep a lot on me when I'm talking to her. She doesn't listen that well. I want to leave you with this great quote from 37 Signals. Solving 80% of the original problem for 20% of the effort is a major win. The original problem is almost never so bad that it's worth 5 times the effort to solve it. And this is when your product folks come to you and they say, hey, I need this new feature, and only like 5 people are going to use it, and it's going to add 100 milliseconds to your startup time. You can really push back against them and say, is this going to make us money? Or is it going to cost more than it's worth to implement that? Another thing is, performance is really, really hard. It requires a tremendous amount of discipline. In another case study by Pinterest, they say there are over 600 JavaScript files in our mobile web code base, and all it takes is one ill-chosen import to bloat your bundle. It's really hard to maintain performance. But the benefit of doing it right and releasing a PWA like Pinterest has done, in less than 6 months since fully shipping, we already have 800,000 weekly users on our PWA like a native app, using it from their home screen, which is pretty amazing. So I actually finished tremendously early. Thank you. Are there any questions? So all the slides are available, and I actually linked to the full one, which has another additional 100 slides, which have a lot more information in it and more in depth about why performance is important. And thank you all for your time.